Hi, I'm Jeff Ranke, Editorial Director of Manufacturing.net and Manufacturing Business Technology. Welcome to Security Breach. When it comes to assessing the threat landscape for OT cybersecurity environments, the challenge has become less about identifying possible sources of attack and more about prioritizing them. Protection from external sources get a lot of attention, and rightfully so, due to the impact of stolen data or denial of service, and how those aspects can be compounded by being extorted for a ransom, or the humiliation of seeing details stemming from the attack broadcast across the web. However, another source of these threats that can be just as detrimental lies within the walls of your facility. Armis recently published a report discussing the devices posing the greatest risk to the industrial sector, and they include engineering workstations, SCADA servers, automation servers or historians, and programmable logic controllers, or PLCs. These devices turned security liabilities have numerous root causes for their new status, including legacy operating systems with outdated security protocols, as well as unpatched common vulnerabilities and exposures that can be weaponized by hackers. Additionally, uninterruptible power supplies, or UPSs, suffered the most attack attempts in April and May of this year. Data showed that 60% of UPS devices have at least one unpatched severe vulnerability. Barcode readers, industrial switches, cameras, and printers were also recognized as highly exploitable devices. We're excited to announce that this episode of Security Breach is being sponsored by Palo Alto Networks. Protect your OT assets, networks, and remote operations with Zero Trust OT security, powered by AI and machine learning while offering comprehensive visibility, Zero Trust security for all OT environments, and simplified operations. For more information, please visit www.paloaltonetworks.com/network-security. Joining us today to discuss the report and the growing number of vulnerabilities found throughout the OT attack service is Carlos Buenano, the Chief Technology Officer of OT at Armis, a leading provider of asset vulnerability management solutions. Carlos, thanks so much for joining us today, and welcome to Security Breach. Carlos, the report was fantastic. A lot of great information in there about some of these devices that we may not think about that can definitely create some issues in the OT environment. Was there anything from the report that kind of stood out to you or was a surprise?
Yes, so definitely the engineer workstations, vulnerabilities that we found, and also these devices connected directly to the internet. So these devices are very, very critical when it comes to operations because they are the only devices that you can actually use to make configuration changes, essentially changing how the plant behaves. These days, most of the frameworks that are, guiding our customers towards cybersecurity, the first thing that they ask us, basically, or they recommend us, is to do network segmentation. And especially when you talk about, ISA 62443, which is actually one of the most common frameworks out there. The first thing that they mention is to make sure that the critical devices. This is actually business critical devices are segmented to a way that no one can get in. Given that that's the message, and it's still able to find those devices on critical infrastructure, it is actually a bit of a concern.
Absolutely. I want to circle back to some of the devices specifically, but you bring up a strategy that we've talked a lot about. We've talked about a lot here on the program, which is segmentation. When you look at the industrial sector, I think there's going to be a lot of listeners and who are going to look at that and say, okay, I've tried that before, but we're looking at some of these devices that are so common and so prominent to the manufacturing space and on the plant floor. Sometimes that it's hard to figure out how to segment some of those different devices. What kind of thought or feedback could you offer there in terms of strategies on trying to implement that type of approach?
And look, this is a path for operational resilience, right? So it's not easy, okay? It's a journey as such, and what we found that every customer is in a different journey, and or different step of the journey, and inevitably the first step for us, to help in this journey is to have the visibility to understand what the devices are, what they are doing, how they are communicating. Essentially, the study that we provided was to give our customers and essentially the community an understanding that these vulnerable devices are still present. And why they're present is because, first of all, they don't have the visibility. They don't understand what they're doing. They don't understand the communications, the behaviors, the business criticality of the device itself. So, the obvious, first step is, okay, let's understand what we have out there, then understand what the vulnerabilities are, and then we can start understanding of how we can segment those devices according to their behaviors, what they are. And a really good way to identify these devices is essentially, again, going back to the frameworks. Frameworks to me are a key part of the journey because, there is a lot of information, like you said before. There is a lot of devices out there. There is a lot of, understanding how these devices behave. And, everyone needs help understanding the journey. So frameworks normally just give you that. And in terms of, industrial control systems, the Purview model is one way to understand. And the Purview model is based on zones and conduits. And what that means is understand the devices, how they behave, and then provide the communication as expected or as recommended by these, specialists in cybersecurity of how they should behave. So going back to network segmentation, these frameworks help you then identify, what these devices should be doing, who they should be communicating to, then start providing some policies around, how they need to communicate. So that's the first step. So the visibility, then understanding the behaviors, and then coming into putting these devices in buckets so that we can define how they should be communicated or communicating, and with devices have to communicate, and then whitelist them in terms of, just providing the communication that are only required.
Yeah. I think that's a great breakdown, Carlos, in the way people can go about and giving them a strategy to really start that process. Because sometimes getting started and down these paths is the hardest part. I think you laid it out very clearly there, and it also kind of reinforces the fact that a lot of cybersecurity in the OT environment, it's sort of your blocking and tackling. It's some of the basic stuff that we can do to become better and just make the bad guy's job a lot harder.
Yeah, look, one of the things that when it comes to OT, and this is actually the most difficult part, is that production needs to continue. It's a money-making network, right? And when it comes to the plant managers, when it comes to the engineers on site, when it comes to the operators, they need to continue. That's part of their work. So they can't just interrupt, production because they have been attacked, and that's the reality of it. So what do? You need to continue on working, and then we need to be very creative when it comes to, okay, how can we protect the network, and then continue production, continue making money from a company point of view, right? Because at the end of the day, that's there's two things that are very important in an OT environment. First one is more important. That's actually paramount. Is people's safety, and the second one is obviously making money, right? So that's what they're there for. So and then it puts people in a very, very, very hard situation when it comes to protecting these devices, because we cannot use the same processes and the same method or methodology that an IT group uses. Okay, let's block these devices because they are starting to infect other devices. No, because that device can be a PLC, or it can actually be a SCADA server, or it can be an HMI, which is essentially the eyes of the process. And if you, in some processes like oil and gas and mining, if you stop the visibility from the process point of view, you got to stop production because you can't see what you're doing, right? And that's actually when we become very, very, very difficult.
Yeah. No, I'm glad you brought up PLCs. That was one of the devices I definitely wanted to circle back on because, I mean, hey, these logic controllers were supposed to be gone 15 years ago, right, with wireless networks, and that just hasn't happened. So the PLCs are still super prominent on the plant floor and throughout the enterprise. Can you talk us through a little bit on how they've become, in some instances, a vulnerability in and of themselves? What is sort of morphed here, and how are hackers using them to exploit the network?
It's a long story, very interesting story.
Yeah.
When a company wants to make an investment for a specific process, build up a new processing facility where we're going to do a bottling machine or something like that, right? So they spend a lot of money. That's actually millions of dollars in investments, in equipment, in engineering, in the place where it needs to be, and there's a lot of moving parts when it comes to designing these devices. So of course the first requirement is I need you to design or provide a vendor, vendor number one, I want you to give me the equipment that is going to last for 30 years, because this is an investment that I'm going to make now and I need to last me for 30 years. Yes, I understand that every 3-5 years, there will be a hardware refresh and things like that, but the technology needs to be supported for 30 years. So what that means to us that, we're looking at technology today that is, not even, 10 years old, that has been designed, 10 years ago when, cybersecurity wasn't as critical as it is today. So essentially, and when it was designed, it wasn't designed or programmed or created with the cybersecurity point of view. What that means is that today there is devices still running, in production that have been designed not thinking cybersecurity, hence they've got so many vulnerabilities. And trying to fix the vulnerabilities means that it's a big process, not only for the actual process owners, but also for the vendors, because, well, first of all, we need to understand what the vulnerabilities are. Secondly, I need to get the vendor involved because they design it, and they designed it 10 years ago, so they need to go back and try to figure out how to get those libraries, that hardware, because they need to be supported, because that was part of the requirement of the contract. So it becomes quite difficult. So obviously the vendors try to do their best to catch up, but the volume of vulnerabilities are released daily, monthly is more than the ones that they can produce. That's actually the complexity that we come with vulnerabilities. And this happens with PLCs, it happens with drives, the VSD drives, it happens to HMIs, happens pretty much with every device that was actually listed on the report that we provided, right? So that's actually the current scape is a reality that we have to deal with. And then, so the vulnerability is one part of it. And then that's why I've emphasized network segmentation, because network segmentation is a more viable way to protect OT networks at the moment until the vendors can keep up with the vulnerability workload.
So, we hear about this a lot, connecting these new components to legacy systems, and it just doesn't always match up right. Your opinion, I know you mentioned there's some onus on the suppliers there. Where does that divvy up? Who has a greater responsibility, or is it a shared workload between the supplier of the new components and the implementer or the purchaser of those new components, and making it not just hooking up to the new system, but it's securely doing so?
One is, configure your network parameters to make sure that the communications that you need are established. That's number one. Number two, use protocols that might not necessarily be secure. At the time that I was actually implementing these systems, we didn't know OPC UA. It was actually in development, and then we had to use OPC DA, which is actually the legacy system. And OPC DA use decom connections. Like if you think about firewall implementation, is 135 port going out and dynamic port going in. So what that means is like that you have to basically open your firewall in such a way to allow the communication. And then, okay, well, what else can we do to minimize the effect? And then you start thinking about outside the box, and then you go into the vendor. Well, we have something that we call OPC tunneler. Okay, let's use that to actually just go around. So going back to your question is like, how do we do this? Well, creatively, we need to go and investigate several ways to achieve the two things. Number one, the connectivity that is required for the process. And number two, the best effort, to implement security. And sometimes the best effort to implement security is not ideal. So that's why, again, going back to segmentation, it's a lot better to get that segmentation in place until the technology catches up, and then we can actually do it more efficiently.
Well, it's interesting, you keep circling back to segmentation, but it's that process of setting up the segmented strategy that really unearths a lot of other elements that you're going to need in terms of improving visibility in your OT system and understanding all the different assets that you have, so you can be accountable for them and understand how they're flowing and functioning, and you can defend them better than obviously. So
exactly. And there's a lot of techniques, right? So if you implement your network properly, you have segmentation, and you can have as many, I want to call it buckets or segments, as many as you want, so that you utilize the firewall to then create those whitelisting links. Okay, I know that this engineering organization needs to communicate with only these PLCs. This SCADA server needs to only connect to these devices, and you actually formulate the policies to ensure that I'm gonna just get the term zero trust. It's like I don't trust anyone. Okay, I'm just gonna create policies so that devices only communicate to the devices that they need to be communicating to. And you say things like, okay, well, I'm not even gonna allow ICMP, or in the old school people come in, it's like, I can't even ping the device. It's like, yes, because ICMP is not open, because I don't want you to discover any device on the network. So it becomes more complex. So what it means is that you need the people maintaining the networks to be a bit more experienced in a way that find the ways to test your communications without using scanning tools to communicate.
Well, and zero trust is interesting, and it's a little bit polarizing in terms of people's perspective on it, but really what it does is it shuts down a lot of those roadways that the hackers can use to getting to whatever asset they're trying to attack. So it makes a lot of sense. Again, when you take a more focused approach on it and not just try to take the sort of one size fits all dynamic and just cover it in an umbrella with zero trust, looking at the segmented exercise and going through it, it can be implemented in a more common sense approach that you kind of laid out here. So makes sense. Carlos, another really interesting part of the report was the fact that there's, whether it's the PLCs, the automation networks, or especially the uninterrupted power supplies, the UPSs, there's patches available. They're not being implemented, and that's what's really making these devices, or turning these devices into vulnerabilities. From your experience, what's halting the implementation of these patches? Is it simply a downtime issue? Is it a timing thing? Is it an understanding thing? What's the biggest challenge there?
So most of these systems depend heavily in SCADA systems, in HMIs, in PLCs. Yeah. And it's not that easy to say, okay, I'm going to turn them off.
Yeah.
To do the update of the UPS.
Yeah.
And because, hey, no, you can't do that, because I'm making changes in the logic to actually create or more effective logic to increase productivity. But I need the power, because I need to test it.
Yeah.
So you can actually, it's like a chicken and egg thing, right? So it becomes very, very difficult.
No, it's interesting with these patches. I mean, we talk about a lot of critical issues in manufacturing, skills gap, inflation, reshoring, all these types of things. These security patches for these OT systems is going to become, it needs to become a higher priority issue and needs to be addressed at a higher level as we continue to go on and understand how do we shut stuff down, how do we deal with the associated downtime to keep our operation secure and avoid those bigger issues that can result from an attack.
And it's one more thing that we haven't talked about is that the patches need to be qualified by the vendors before they can be applied, especially in OT environments. So for instance, let's just talk about Purdue model for a second. So we've got your level 0 and level 1, which is actually the PLCs and the field devices. But then from level 2 onwards, it's supervisory, right? So it's essentially Windows devices. They behave exactly as any IT device, of course. And then, the common sense will tell you, well, if they are Windows devices, why don't we just install the patches as they are released by Microsoft or whoever the vendor is, for that specific device. But the reality is that every patch needs to be qualified by the vendor, especially the SCADA or the DCS systems that are on site. And you can imagine that every time that Microsoft release a patch, that means that it's a project for the vendor to say, okay, let's do QA or go through a QA process. So install the patch just to see if we break something about my system, because it could actually be the case that you install the patch and the SCADA server stops working or the DCS stops working, and it happens.
When we look at all of these different legacy systems, new components, a lot of the different patches that are not happening, they're creating new vulnerabilities. Are you seeing any particular tactics then that the hackers are using to exploit these vulnerabilities, whether it be dropping malware, trying to harvest data, denial of service attacks? Are you seeing any trends there in the types of attacks?
Look, the reality is most networks in OT environments are air-gapped in a way, right? So then there is a lot of social hacking. We actually, when I was actually working on this company in Australia, it's an energy company. So essentially, we did an experiment where we actually paid someone to come in and see how deep it could get into the control system. And the reality is that even though it wasn't a very planned methodology to get into the control system, it was easy. So he got infiltrated into the office. There is a lot of hot desks when it comes to, come sit down. People see this person that you don't know, then, okay, it's in a hot desk. He might, he should be there. Maybe he's actually a contractor or something like that. So he actually started doing social engineering and then find a way to get into the SCADA system. And obviously he didn't do anything, but he proved that he could actually shut down production just by working a week in social engineering, right? So, and that's the reality. The reality is that social engineering is a big part of how hackers these days can get in. Of course, they have, a lot of, a toolkit of vulnerabilities that they can take advantage of. The reality is that it's becoming a business. You have ransom as a service now. That's a sad reality. And even more sad is the fact that they are doubling up revenues year after year. So and they are actually using that type of mechanisms to get into control systems and do the damage that they do.
Yeah. All right. So we'll circle back to the bad guys, but let's maybe try to talk about the good guys a little bit. Carlos, can you tell us a little bit more about some of the stuff that Armis does?
Yeah. So we help customers throughout the journey that I mentioned initially. Okay. So the first step for operational resilience is, visibility. Let's have a look at what the device is doing. Okay, we do this passively. Essentially, we understand that the critical networks cannot be scanned. So then we then start with installing a sensor on the networks and start monitoring all the devices that are talking on the network. So we start then looking at evidence from the traffic, and then we not only discover all devices on the networks, but also then we start identifying and then defining the devices for what they are, what they're doing, what they're connecting to. So the whole point is for us just to understand, behaviors, whether it's actually the behaviors that they're expected to have or anomalous behaviors. We start looking at details when it comes to hardware information. So these details then we can then start looking at matching vulnerabilities with the hardware that they have. Also looking at life cycle management. So understanding what devices, talking about 30 years lifespan of OT devices. Let's have a look at which devices are end of life, end of support. Help you understand the vulnerability of those devices, the risks of all devices. We start looking at risk assessing every asset, understanding the type of traffic, the traffic protocol that they use, whether they are actually an encrypted protocol, who they are communicating to, and then going back to that report that we released, and it was all about understanding what the devices were and what they were doing. And the last thing, we help remediate with the remediation.
Interesting, great stuff. Carlos, as we kind of wind down here a little bit, I'd like to get your thoughts on just some bigger topics that are sort of prominent right now in industrial cybersecurity. Your report focused a lot on devices. There's also a human element to all those devices as well. It's not just the machine. There's a human being that's involved in positioning them, accessing them, using them, all of those types of things. What have you seen maybe as some best practices, especially when we look at devices that are a little bit more of an add-on type, when we look at cameras, barcode readers, those types of inspection equipment especially? What can we do? And part of it is probably just educating people, I know that, but have you seen some best practices, I guess, in really raising the level of awareness and understanding the worker or human element of cybersecurity as well?
Yeah, so, and it's my comment about, social engineering is always there, right? So a part of, part of the human education is help them understand the risks that they have, when they receive an email with a link, things like that. Very simple stuff, right? So that's actually the first step, right? Help our people understand that there is always risk. Help people understand, what a fake email is, what a real email is. Simple stuff. That's actually something that is a must. People need to understand, when, if any. I particularly don't click on any link. I just go straight to the source and find out information, right? But it might not be easy. It might be a bit of more, but once you get used to it, it's fine. Password management, the sticky note on the laptop or the computer with a password. You won't believe how many times I worked into a place and they have a massive whiteboard with the password for different systems. It's like, okay, if I can see that. I walked the other day. I walked into a car park, and they have logged me in display on the boom gate of the car park, and it's like, okay, and I can see the password and everything. It's like, okay, should I just do something about it? Anyway, so the first step is obviously education. The second step is prevention, right? So, and prevention is very important always. So IoT devices, we know that IoT devices are very, very, very difficult to protect, because you can't install an agent. They are, the firmware that they use are normally developed using shared code. And once they are in the firmware, it's really difficult to maintain updated if you don't have the visibility that, for example, the visitor we talked about before. So you don't know what version, framework version they're using. You don't know the vulnerability. It's very difficult. So for that, to prevent, you need to keep those devices in separation to the production devices, right? So especially cameras, very important for security, not so important for production. There are benefits in a way to put cameras in a production environment to understand whether or not are people present before you start up machinery or something like that. But at the end of the day, you can't just rely on that because, again, it's always a human factor, isn't it?
No, makes a ton of sense. The other thing I wanted to get your feedback on is one of the things we're hearing from a lot of people in the industrial sector, a lot of listeners to this podcast, is just the influx of tools that are currently available. This is a good problem to have. Okay, it is great that there's a lot of potential solutions out there, but it can get difficult. It can get difficult to choose, and it can be difficult once you have all of these products in-house to understand the best use for each one. What advice could you give to folks, number one, in picking the right products, and also then on sort of keeping them organized and targeted at the right solution?
I think, again, it goes back to the framework. In OT environments, it's important to understand what the end result is, what you're trying to achieve with the tool. Okay, so that's very important, and then understand whether or not the tools are overlapping between each other. Understand, how you can manage those tools. Okay, so these days there is a lot of tools, yes. But there is also mechanisms to correlate the information into one tool. When you select a tool, you need to make sure that you somehow are feeding that information into your risk assessment. So you have an actionable control, something that, okay, what happens if I find this information that the tool is giving me? I want to do something. It's not like I want to have it because it's just to have, or because the framework is telling me, no. I want to have the information because there is a direct action that I want to execute when I find this information. And that's actually the best advice that I can give you right now.
Yeah, going back to that if-then type programming logic makes a lot of sense.
Exactly.
Absolutely. Hey, Carlos, this has been awesome. Just kind of wrapping up here, are there any big trends or things that you're seeing when you look down the way a little bit that we can expect to experience, or we should be looking to gain a better understanding of when it comes to industrial cybersecurity?
Look, I can't help not talking about AI. Right. So
see, I knew I didn't have to bring it up, and it would still be something that appeared. So
look, it is coming. It is coming strong. I use it every day, to be honest, with several, not only for information, but also to understand the trends and what is happening. It's one of those powerful tools that if you use it in a good way, it can provide some benefits, but you can actually also use it, to create damage. And we already seen the trend, from these systems or this RAS as a service that I mentioned before, ransomware as a service. It is becoming very scary when it comes to providing information that even we use a lot of information. Armis uses a lot of information to prioritize vulnerabilities using threat data to help the customers to prioritize vulnerabilities. But they are using AI to do the opposite, to find the vulnerabilities quicker from systems so that they can take advantage of it. So it's a war now, and it's going to become more and more obvious to all of us.
Thanks, Carlos. And for more information on Armis and their offerings, you can check them out at Armis, that's ARMIS.com. Thank you for joining us today. And to catch up on past episodes, you can go to manufacturing.net, IEN.com, or mbtmag.com. You can also check Security Breach out wherever you get your podcasts, including Apple, Amazon, and Overcast. And if there's a story or topic you'd like to see us explore here on Security Breach, you can contact me at jeff@ien.com. For Carlos Buenano, I'm Jeff Ranke, and this is Security Breach.